It's go time. Boom. All right. Take a look up here. I hope we get most of these right. Like I said, and not bragged. So proud of one group that decided to write on the board and nailed it, knocked it out of the park, and then the rest of the class started copying their answers. Anyway, is that right? Okay, I didn't copy me. All right. All right. So if you look at this from 0 to 2 pi, then this is pi. So this goes from pi to negative pi, one cycle or one period. So that means the period is 2 pi for tangent, and you'll find out for cotangent. But for some reason, AP throws that at the end. We should be graphing cotan right now, but they're waiting. Do you have a pass? You come from the dean's office and they don't give you a pass. What is wrong with this school? They should follow the rules. Anyway, huh? No, of course, the machine's broken. Typical. All right. So anyway, pi over b equals 2 pi, then switch them. And then that means in the equation, b would have to be a half. How many people got that right answer? Because he copied. Next. I'm just kidding. All right. Negative pi over 6. Hopefully, 5 pi over 6. Hopefully you remember over 6 is, that was root 3 over 3 for tan. Is that what you guys remembered? And then for over 3s, it's root 3, and then cotan switches with those. This is, we really tried to hammer those ratios in your head. How many people got that? Do I have to really continue with this? Some people real quick sketch the unit circle, right? And that's fine for these kind of questions. These can't go away. You got to, come back to these real quick. A negative 3 pi over 4 is in quadrant 3. Always tan and cotan of over 4s is 1 because it's a 45, 45, 90. 1, 1, root 2. You guys remember those? And it's 1 over 1 for tan, y over x. And then I just made a quick sketch for 9 pi. um, at 9 pi, that lands where pi is, basically. Negative 1, 0, and it's 0 over negative 1, y over x. Um, I like this question. This is purely what AP likes to do. So what I did is I put a sketch based off of yesterday's notes when they moved around the unit circle and talked about input, say it. The output is actually the slope of the line. That's what tangent is, the slope of the ray moving around the unit circle. So the first slope is at 0. So at 0 radians, you get 0 for a slope of that line. 0 comma 0 is our first point on the graph. Then as we move to 45 degrees, and I'm going to use degrees. We should really talk about degrees. That's pi over 4 radians. That's when the slope equaled 1, just like I talked about up here. Always an over 4. Tan of over 4s are 1 or negative 1, depending on what quadrant, of course, to be correct there. So if at pi over 4, the slope is 1, as you're moving around the unit circle, before that, that's when you're less than 1 for a slope. Then after that, it's more. So that's why 3 pi over 16 is the right answer there, because that's less than 4 pi over 16. So therefore, you'd have a slope less than 1. So it's that cryptic, understanding, what we did yesterday. It's a really good question to follow up from yesterday's movie. Unless you didn't watch the movie, then you don't know what's going on. Next. So I put a real quick sketch of the graph, and then we talked about concavity. Before that point of inflection, that is concave down after it's concave up. So that is the interval where we have a concave down. It's always increasing, but that first part from negative pi over 2 to 0 is concave down with no equal signs. That's just up to those points. How many people got that right? I know the people at the board did. Good little question again. And then finally, a quick sketch of this graph. Okay, now hopefully I did this right. I kind of smacked it down real quick, but the period is pi over a third. So I yelled at you. This was bad on our cosine sine test when we had cosine of x over 3. Some people were saying the b was, or it was like 1/3 pi for the actual period, but it's actually pi over 1/3, which is 3 pi. Right? So knowing dividing, flipping, and then for tangent, had to grab the right trig word, half the period left and right of 0, comma 0 is where the first asymptotes are. So 3 pi over 2. And then we are, discussion with the other teachers this morning, going to make sure that you do get these quarter values where these other coordinates are, the A values, if you will. But we're also shoved down one, so we got to be careful. So just to do a quick sketch of this, you're down one, so this isn't at 0, 0 anymore. And then this is down 2 and up 2 because it's flipped. So it's upside down. It goes this way. It's not increasing now, it's decreasing. So 2 away, 2 away. So that's why we want those X values, and those have to be marked. Okay, with that being said, the real question is, what's the equation of the asymptotes? Well, one of them is at 3 pi over 2, and they're always the period away. And then I used K instead of N. It doesn't matter. I kind of like N better, I've told you, because K, sometimes my Ks look like X's. But when it's typed, it's not that bad. I see some of you just copying every single thing that I did here. You're severely and totally, say it, behind. You're supposed to be correcting and hopefully get 3 out of 5 right. All right, but anyway, that's how I roll. All right. So now we got a problem. I told you this is the worst when things happen. We now have, let's put what this is all about here, phase shifting. And we're going to approach this the same way. So if I didn't say that in the beginning, those first 5 questions, someone went up on the board and did it. That was supposed to be done in class, and we're just showing the answers after having evidence of it. Okay, now we got a problem. Phase shifting can be a problem, can be a bit of an issue. So what we're going to do is graph our graph without a phase shift with X's. Remember, we did that? That was actually, we were talking about that today. We saw someone do that in flip math videos, and we're like, we really like that. And it actually is a good way of handling a very, very complicated phase shift scenario. All right, and we are going to ask you to, instead of graphing from 2 pi to negative 2 pi, we're probably going to be more on graphing 2 cycles. By the way, I could have graphed 2 cycles on this. I had an idea that I wanted to do that. Even the ones on the board, I said, just do 1 cycle. But another cycle could just be as simple as this. Listen, 3 pi over 4, because I want to do it on the next one. 3 pi over 4. Add another 3 pi over 4, and that's 6 pi over 4. Everyone look at that. Isn't that 6 pi over 4? Because then what's the next one? No, come on, say it. 9 pi over 4. Oh, I don't want to put that there because that's where my that one value is going to be. So, I'm freaking out, man. This is in my way. I do want to... Okay, fine. I'll put this up here. 9 pi over 4. And then what's the next one? 12 pi over... What's 12 pi over 4? 3 pi. I guess I could put this up here. And then 15 pi over 4, which that's 15 pi over 4. And then what's the last one? 18 pi over 4. Right? What's 18 pi over 4? 9 pi over 2, correct? 9 pi over 2. Now I'm going to double check this. Yeah, because 6 pi over 2 is 3 pi, so these are 3 pi away from each other. Got it? Right, so I know that that's true. So what I did is I just kept adding 3 pi over 4 to get each next, these equal increments kind of situation. All right, and then this is where an asymptote is. This is why this is the second period. Yesterday I did half here and the other half on this side. If it's 2 cycles, just get a full cycle to the right. And then this would be the 1 value, the -1, and the -3. And then there's cycle number 2. But here's the thing. And this is what went really bad on the last test. We did not do a good job of finding these values. And, these critical values on the x-axis. That's what it means to find critical values. The x and the y-axis values that I just noted there. If I ask 2 cycles. It's really just fraction work. It really is. All right. So we'll attempt to do the same thing on this complicated question. Luckily, I believe the phase shift works nicely with the period. So I always forget that the period's over here. Let's move my fat head out of the way here. Go up there. I don't know why I'm obsessed with having my picture there, but I just kind of like that, I'm doing this live in class. So the period is pi. For those that didn't do their homework when they were absent, tangent, the parent graph has a period of pi. So all baby tangents are compared to that, not 2 pi like sine and cosine. You'll find that cotangent is the same. I don't know why we're not doing cotangent right now, but we're following the AP like robots. Right? And then we'll get the range later. I could have done, oh, well, no, we're not. What's the range, everybody? Always. All of them. All of them. Did you hear? Wow. Did you hear that? All right. Very excited. I know that one. All right. Okay. So now we're going to do this without graphing yet. So if the period, oh, I hate this. And they do have, so we're going to practice this and then we're going to manipulate this one and space it out a little bit more. I don't like when they have already 2 pi to negative 2 pi listed, because then this is actually going to be very, very, very small. I almost want to destroy this. Ugh. Okay, but I guess I'll leave it. Okay, so the period's pi over 2. So that means my first asymptote is here. I got to make this a little bit thinner because I have to zoom in here, as pi over 4. Remember, for tangent, the first asymptotes are half the period left and right of 0, 0. All right. We haven't phase shifted yet. So, and don't draw an asymptote, because then your graph's going to be an absolute mess. You're going to draw your before phase shift asymptotes, then after. You're going to have dotted lines running all over the place. So I don't know how to mark this as an asymptote. Maybe we'll just leave it. All right. Because then these we can mark as X's. We know it's going to be at 0, 0. We have to phase shift that though. And then we know that this is going to be at pi over 8. So this is why I don't like when this is marked as 2 pi to negative 2 pi. Don't like it. As a matter of fact, I think I'm going to, when we have a test question like this, that we're going to make this spread out a little bit more. And I'll show you how spread out I'll make the next one. All right, and then these points, okay, let me analyze the graph further. We just have 1 in front. What's the amplitude, everybody? 3, 2, 1, go. None. You're gone, because they didn't watch the movie because they were flying a little plane last night. All right? No, there's no amplitude because there's no high or no low point. So if we're a jerk and ask that question, do not just say no. Nope, you're not getting me, Mr. S. All right, and then that pi over 8. Let me erase that. What time is it up there? What time do we got? Wrong. It's 1:11. All right, you got that wrong too. I'm just kidding. There's something wrong with my clock. I am leaving in an hour though, because that's what it says. So. All right. And then this goes here. Wrong. X marks the spot. X marks the spot, right? Okay. X marks the spot. Okay, now, what is the phase shift? The phase shift, easy for me to say, is pi over 4. Which direction? We should know that. 3, 2, 1, go. Right. And now, okay, it's really not that bad. I do have the critical values given. This is why the phase shift works nicely. This is phase shift pi over 4 to the right. Maybe I'll change colors. Now that's where my asymptote is. I hit that, jerks. All right. So do you get it? Do you get it? Do you get it? This phase shift, this was the asymptote, and I pushed it pi over 4 to the right. Now it tells me where everything else is. And now I think I'm good to go. Because then this pi over 8 goes to here, and now it's this point right there. See it? Do you see it? Do you see it? And then this was 0, but it's moved pi over 4 to the right, so it's there. And then this one was moved pi over 4 to the right, which is here. I feel like something's off here, but it's not. And then this pi over 4 moved to here goes to here. That's actually really nice. So it is nice when the phase shift actually matches like a fraction of the period. Sometimes it doesn't. Then it's a real mess and it's a real pain in the behind. And then what I could see is, all right, fine, I'm good, man. When we do this, we might ask you for the X values. So it's pi over 8, 1 pi over 8, 2 pi over 8. This is 3 pi over 8. Again, I don't have enough room for this, so I'll put this down here. 3 pi over 8. 4 pi over 8 is already given. It's pi over 2. And then this is 5 pi over 8. Yeah, I want that up here. This is 6 pi over 8. Oh, 6 pi over 8. My brain's actually hurting right now. Is that 3 pi over 4 reduced? I think, and then that's a 0. 3 pi over 4. This pen is a little too thick, or I'm too scrunched on this drawing, and I don't like it. 7 pi over 8, and then the other one is 8 pi over 8, which is pi. All right, and then you got 1, -1, sorry, and 1, and then you got another value. So this is why 2 pi to -2 pi is not so great. All right, all right. Good, we're doing well. All right, we're going to do a better job on this one. Okay, what? Okay, what is the domain then? All right, so the domain is what the asymptotes are, but let's just do the domain, which the difference between domain and asymptotes, x such that this is a not equal to sign. This means x can't equal that, right? We'll just do domain from now on. All right, you don't have to do both, but I did want to make that distinction here. Well, guess what? Where's your first asymptote? Right at what number? 0. So it's actually just 0 plus, and then where's the next? Like, how far away are they from each other? Pi over 2. So really, to write that, you don't need 0. It's just pi over 2. Let's use n. Let's keep going back and forth. N, k, k, n. It doesn't matter as long as you define n as an integer, which is that NEZ thing. Just do it. It's actually a mathematical true structure. NEZ means element of integers. Thank you for stopping me. My nose is itchy. I don't know why. All right. Keep scratching it annoyingly. Okay, I don't have an up-down shift, so I am going to use this A as 5, because if you count 1, 2, 3, 4, 5, we'll really see that stretch right there. What's wrong? You guys okay? All right, next thing, we do want to rewrite this. I'm going to rewrite this above. This is tan. I guess we're staying green for a minute. You got to pull that 4th out. Oh, you want to get nuts? Let's get nuts. What does this pi over 2 become when I pull out a 1/4? Is it pi over 8? I mean, if I put pi over 8 here, what is 1/4 times pi over 8? This is what the common answer is. Pi over, just when you take 1/4 times 8, you just take 4 times 8 on the bottom. You guys kill me. Okay, so what is 1/4 times pi over 8? Pi over, let me get my calculator out. 32 times tables. So this is wrong, and I heard you say the right answer over there. 2 pi, baby, 2 pi. Okay? Because when I throw a 4th in there, 2 pi over 4 is pi over 2, so it equals. Good FOILers? Good factors. You missed that one. Input? They're doing a dance back there. I have no idea what's going on. All right. So anyway, I think she's just doing a dance that I got the answer right. Dance. That's what it was. Okay, so this is pi over 1/4 for the period, which is 4 pi. Now look at that. 4 pi with a phase shift of 2 pi, that's going to be a multiple of the period. This is going to be a nice one again. All right, and then I guess that's it. What's the range, everyone? Hurry up. Do your dance. Oh, too late. All real numbers. Input, say it. Yay. All right. Now, I can do whatever I want. I guess I'll go by like 2s. I don't know. I just want to spread this out. I don't want to have what happened to me in the last one. So I'm going to go. Oh, by the way, the period's 4 pi. So where is here? Here's what I'm going to do. I'm going to go by 2. So what is this? This is where an asymptote is. Is that 4 pi or what is it? Before my phase shift. 2 pi. It's half of that. So let's go 2 pi. 1 pi. Oh, this is so easy. Negative pi and negative 2 pi. I do want that because then if I want to do another cycle, then I have some space. Okay, like I think on the key for the cosine kid quiz, I went 3 spaces, because it was nice to space that out just because. Anyway, blabbering. Okay, so for this is where there's no negative. So this point would be the 5. This would be the 0, and this would be the -5. There's that stretch. So we got this tangent curve, but it's really stretched out at those points. That's the meaning of those. And then those are where the asymptotes are, but I don't want to draw those. It's going to be, you're going to destroy your graph. It's going to be ugly. And then which way do I have to go? What is the phase shift? 2 pi, which direction? left. So I just want to take one of these. This is almost exactly like the last one. 2 pi left is the same thing as 2 pi right. It really is. If I went 2 pi right or if I went 2 pi left, this is where the asymptote would be again. It'd be right on the y-axis. So if I move this 2 pi to left and this is supposed to be an asymptote, then my asymptote is here. Maybe green doesn't show up very well. And then I get what's going on here. 2 pi left is the same thing as 2 pi right. So this would be my low point. This would be my 0. And then what I have to do is find some more values, like 3 pi, right? Come on, that's not even hard. And then 4 pi. And then that's where my next asymptote is. Okay, so what I kind of liberally, I said I was going to graph this in green. Kind of liberally knew like the spacing of everything. Once I knew where one thing is, I know where the rest of it is kind of like the idea there. And then to do 2 periods of this, by golly, all you got to do is cut and paste these negative values over here. Negative 3 pi, negative 4 pi, and then do another graph, right? I'm just going to be lazy and shut the movie down. Is everyone okay? All right.